Hey everybody, so today I'm going to go through the Unit 4 study guide, and it's not really a study guide, it's more of like a Google Slides that shows you how to do certain skills that you'll need for the test for next week. So let's go on and do this first one here. It says click and drag each quality to either ionic or covalent. So if you want to quickly review ionic or covalent, ionic is going to be whenever you have a metal and a nonmetal, and the metal is going to give up electrons, and the nonmetal is going to take them in. Alright, and the ionic ones, those are going to be the ones that conduct electricity, and they're going to be made up of kind of like a lattice structure. And when I say a lattice structure, it's just like a giant block of alternating positive and negatively charged ions. Alright, so let's click and drag these. Alright, so from what I just said about ionic compounds, alright, looks like this first one formed when two atoms share electrons. I don't remember saying that, so let's hold off on that one. This next one formed when one atom gives up electrons. That's an example of that one. I did say a metal and a non-metal. Alright, and made up of a lattice structure, so that one's going to go there as well. Alright, the next ones, this one and this one, I did not say those just now, so it looks like those are going to go into the covalent category. Alright, so that one was pretty easy. You just had to click and drag each quality. Alright, next one, it says click and drag each element to its correct charge category. Alright, so and if you don't remember this, you can take out your handy dandy periodic table, and you can look and see what column is each one of these in. Alright, so for example, this first one, aluminum. Aluminum's going to be, let's see, it's like right to the right of the transition metals, and it is +3. Alright, so I'm going to click and drag aluminum to the +3 category. Alright, magnesium, it is in the second column, so it's going to be +2. Alright, strontium is just further down the column from magnesium, so we're going to put strontium right there. Alright, gallium Ga, that one is going to be underneath aluminum, so since they're in the same column, they're going to have the same charge. Alright, K stands for potassium. K is going to be in the first column here, so that's going to be +1. Alright, beryllium is above magnesium on the periodic table, so Be is going to go there. Alright, Li is number 3 on the periodic table, that's its atomic number, but that puts it in the first column, so it's going to be +1. And then cesium, or cesium, however you want to say it, cesium or cesium is going to be a +1. And then francium, I believe, is in the first or second column. So if you're unsure, let's just Google a periodic table, shall we? Periodic table. Alright, periodic table, P table. Alright, so francium, actually it's in the first column right here with cesium, rubidium, potassium, sodium, lithium, all those. So let's click back here, and we're going to drag it into this +1 column. Alright, so that was pretty easy. Alright, next one, it says click and drag each element to its correct charge category. Alright, so it's got +1, +2, +3, +4, +5. Alright, and all of these are transition metals. In transition metals, it gives you the charge in parentheses outside the name of the element. Alright, so starting over here, osmium, and it's got a V here. The V is going to stand for 5, so we're going to click and drag that one to the +5 category. Alright, copper, this one here has a 1 in parentheses, so let's put that one there. Alright, copper, this one's going to be 3, copper 3, so we're going to put +3. Alright, iron's got a V, which means it's got to go over here in 5. Alright, iron, this one has a 4. IV is 4, so we're going to click and drag that one to the 4. Alright, zinc is going to be right here, where it says 2, +2. Alright, silver has an I, and that's 1. This iron here has a 2. This manganese has a 2. No, that's a 3. Sorry, I saw that wrong. Platinum has IV, which is going to be 4. And then this last one here is scandium with a V. That's scandium 5. Alright, so I click and just drag each one of those to its correct charge category. Alright, next one, it says put the steps for writing the correct name of binary ionic compounds in the correct order. Alright, so binary ionic compounds have one metal and one nonmetal in them, and the nonmetal is going to end in IDE. All right, so the first step for that, and we're writing the name of it from its chemical formula. All right, so we've got this first one here, write the name of the metal from its symbol. If the metal is a transition metal, write a Roman numeral, change the name of the nonmetal to IDE. So I would say this is the first step. You want to write the name of the metal from its symbol. Step 2 is you want to check and see if it's a transition metal, and if it is, you're going to need a Roman numeral. And then finally, you're going to change the name of the nonmetal to end in IDE. So again, remember, some of the IDE endings are what they will call irregulars, and that's what this next chart on this next slide is showing you. All right, so it says, in the chart below, fill in the IDE ending, and it gives you the name of the nonmetal and the IDE ending for it. All right, so we've got sulfur here, and this is not going to be sulfuride, it is going to be sulfide. All right, next one, we've got nitrogen, and it's not nitrogenide, it's going to be nitride, like so. All right, next one, it is not phosphoruside, it's just going to be phosphide, like so. All right, bromine is an easy one. It just changes the INE to IDE. So this one's going to be bromide. All right, carbon we didn't really do a lot of, so it's going to be, is it going to be carbonide? No, it's just going to be carbide, like so. All right, oxygen is the easiest one. It's not oxygenide, it's just oxide. And then arsenicide, no, that doesn't sound good. Let's just say arsenide. All right, so there are the IDE endings for each one of those. All right, so going to the next slide, number 7. It says, put the steps in order for writing the chemical formula for the binary ion and compound. All right, so we've got 6 steps here. All right, so we've got, yikes, this is a lot of reading here. All right, the first thing we want to do is when we write the chemical formula for the ion and compound, so we want to write the symbol of the metal from the chemical name. So that's this purple one here. So I'm going to click and drag this one to here. All right, step 2, I'm going to move this one. Step 2 is we want to determine what the charge is of the metal and write it above there. Oh, look, so that one's that one right there. So that's step 2. All right, step 3, we've done the metal. Now we want to do the nonmetal. We want to write the symbol for the nonmetal from its name, like so. We want to determine the charge of the nonmetal. We're going to crisscross or cross down the charges, and then finally we are going to simplify the subscripts like so. And for some reason this one's being weird. Alright, so there we go. Alright, so there's 1, 2, 3, 4, 5, 6. There are the 6 steps. Alright, for this next one here, you're going to need your polyatomic ion sheet. So it says click and drag the polyatomic ion to its correct charge. And I have all of these memorized in my brain, so you might need your polyatomic ion sheet. So in each box, it's giving you the chemical formula for a particular polyatomic ion. Alright, so I'm just going to start up here. PO4, PO4, is it -1, -2, or -3? And I know for a fact that it is -3. So I'm just going to click and drag it here, put it in that little triangle. Alright, ClO4, I believe, is chlorate. And chlorate is -1. Alright, NO3, that one is going to be nitrate. And I'm going to click and drag that one there. Alright, next one, we've got CO3. I know that one to be carbonate. And the charge of that one is -2. Alright, next one, we've got SO4. SO4 is going to be known as sulfate. So let's click and drag sulfate to -2. Alright, next one is going to be SiO3. And that one I am not sure about. So let's Google what SiO3 is. Alright, so SiO3. Let's see what it is. SiO3. Oh, silicate. Okay, and it says it is looks like it is -1. Alright, so that one is going to go over here. Alright, next one is, let's do ASO4. I think that one is arsenide, or arsenite, or arsenate. I think it's arsenate, and that's -3. Alright, O2 is going to be peroxide. Alright, anybody know what peroxide is? Alright, let's see. peroxide charge. Alright, so it says the peroxide ion is O2 with a charge of -2. So let's go back here. It's O2 with a charge of -2. So I'm going to click and drag that one into here. Alright, we've got OH, which I know for a fact to be -1. And then finally, we've got BO3, which is borate, and that's going to be -3. Okay, next one. Alright, so this is the flowchart that we did the other day. So it says, how many capital letters does the compound have? Alright, if it's got 2, what is the name of the type of compound? That's going to be binary ionic. How to name it? Write name of metal. Change ending to IDE of non-metal. And that's, I know my font is way too big. Alright, next one. More than 2 is going to be a polyatomic compound. How to name it? You are going to write name of metal, and then write name of polyatomic ion from sheet. And I'm going to change this to be a lot smaller so it'll all fit in this box. Alright, and I'm going to leave out the examples because I'm really running out of time right now. I only gave myself 12 minutes to do this, and now I'm running out of time. Alright, so now in this one, you're going to want to fill in the number of capital letters and if it's polyatomic or binary ionic. Alright, so this one has 1, 2, 3. This has 3 capital letters. So this is going to be polyatomic. Okay? This one down here, the next one in the chart here, this one has 3. This one only has 2, though. So it's going to be binary ionic. Alright, and you can do this one. This is where you just have to fill in the prefixes. This one here, you have to determine whether or not it's correct or incorrect. And I'm really running out of time here, and I try to keep this under 12 minutes. So like oxygenide is most likely wrong. Magnesium 2 dioxide, also wrong. Well, I'm out of time.